Howdy-o, neighbors. It's Mr. Orga again, Unit 9, Lesson 4. Hope everybody's doing all right here. Our goal in this one is to solve the quadratic equation by factoring, so that is our objective. Just got a little example sitting here for you. You take the 1, we got to go back to our chapter where we did factoring in 7. You factor it. It's going to be set equal to 0 here, and we're going to do something called a t-split here. Done different ways by different teachers, but that's what I'm going to call it here in this chapter. Okay, let's get started. Go to exercise 1. All right, in exercise 1, we're to solve each of the following equations for the value of x. It's pretty straightforward. We've already talked about this in the past. What's the opposite of squaring something? Square rooting. So you take the square root. X is equal to, everybody says square root of 16 is what? 4. Good, it's a 4. But when you take the square root, if you remember, we talk about you got to have a positive and a negative version, because not only does 4 times 4 equal 16, but negative 4 times negative 4 equals a positive 16. So we're going to have two answers, plus and minus 4. Pause for a moment, take a look at B and C and try that on your own. Okay, hopefully you did it. You took the square root of 100, so x turns out to be not only 10, but negative 10, so plus or minus 10. And if you took a look at 20 here, that's a little bit tougher. When I do that, yes, I get plus or minus the square root of 20. Well, we can bust up 20 into 4 times 5. Well, what's the square root of 4 part? That's a 2. So we're going to have plus or minus 2, and then the radical 5 is not coming out. So part of our answer is going to look like that. So plus or minus square root 2 square root of 5, okay? And you're going to see a lot of that. So we're going to take a look as we go along, busting it all the way down, which we've done in the past. All right, let's go take a look at exercise 2. All right, we got some work in this one, and I'm going to probably lead you through most of these because they're a little different each. We're solving for this one. And what we're going to do on this type of a thing here is we got a couple ways. We're going to see it another way in the future, but I'm going to deal with it like we did in the first one here. One option is to move the 10 quickly to the other side, minus 10 from both sides. You will get 2x squared equals, then 28 minus 10 is 18. And then we can get rid of the 2 by dividing by 2. So I will get x squared equals 9. What do you do then? Take the square root of both sides. So what's your answer? X equals plus or minus 3. Okay? Always remember to check back. Make sure you're good on that one. All right, moving on to the next one. I add 5 to both sides first. So I will get x squared divided by 2 equals, when I add 5 to both sides, I get 8. How do I undo the 2? Well, it's being division, so the opposite is multiply both sides by 2. So I will get x squared equals 16. Now I'm ready to undo the square part last. Take the square root of both sides, and you will get x equals, remember, plus or minus, because I'm taking the square root of square root of 16 is 4. All right. Next one, we already have a perfect square sitting here. I want you to see that. See that perfect square already there? Nothing on the outside. But it's different because of the minus 2. I cannot move this to the other side yet because I got to deal with that exponent first. It is on both the x and the minus 2. So all I do is treat it like this was just an x here, and you take the square root of both sides. The square root of this perfect square means the square and the square root here, they cancel. So I get x minus 2 comes out. I can't do anything with it. Equals plus or minus square root of 25 is 5. So now a lot of you guys are saying, well, I move the 2 over next, plus 2 to both sides. That's true. When I do that, I get a positive 2. So here's my answer, 2 plus or minus 5. Well, can't we figure that out? One answer is 2 plus 5, which is equal to 7. And one answer is 2 minus 5, which is a negative 3. Those are your two answers when you do this problem, okay? So you take care of that at the end. And because they were both numbers right here, I can split them up. 2 plus 5, 2 minus 5. That's how you deal with that. Okay, we're going on to our last type right here. Same type of scenario here. I would first, though, this time, I've got extra stuff here, don't I? So I would add 50 to both sides. That's what I would do first. It's going to take a lot of writing, so squeeze yours in there. So I get 2 times x plus 5 squared equals, when I add 50, it's called 200. Then I got to get rid of this 2 out in front, so I divide both sides by 2, and I get x plus 5 squared equals 100. And now I'm down to that square, so how do I do squaring? Square root both sides. So I will get x plus 5 equals plus or minus 10. Okay, because square root of 100 is 10. So then I subtract 5 from both sides, and I get x equals negative 5 plus or minus 10. Well, let's get our two answers here. I'll change colors as you can see that one here. I'll go to orange this time. And so I will get x equals negative 5 plus 10, which of course is 5. And I get x equals negative 5 minus 10, which is negative 15. So those are my two answers. Sorry, running out of space down here. So 5 and negative 15 are your answers for that one, okay? Bunch of work there, not too hard. It's just like solving we did with our first and second units of the year, and then we're dealing with the square root stuff from a couple of units ago. All right, let's move on. All right, in exercise 3, we kind of do the same thing. Once again, I got an equation here. I'm going to add 2 to both sides. And when I do that, I get 5x squared equals 40. And then I divide by 5, and x squared is equal to 8. How do I undo squaring again? I take the square root. That's 2. When I take the square root of 2 on both sides, once again, x is equal to plus or minus square root of 8. Well, square root of 8 is not a perfect square, guys, so we got to bust it up. Got a perfect square of 4 and another number called 2 make 8. So our final answer is plus or minus, the square root of 4 is 2, and I have a radical 2 that cannot come out. And that's the way you're going to write it. There's nothing wrong with that answer. That's a solid answer. And they're going to come like they told you, gave you a clue in the thing. You'll have answers in radical form. So leave it that way. Okay? No decimals, none of that garbage from the calculator. All right, number B, you're going to move the 10 to the opposite side. It's a little different again, so I am going to go through this one with you as well. X minus 3 squared equals, and 38 minus 10 is 28. I am down to, in parentheses, a perfect square, so I'm going to take the square. There's nothing else on that side, so square root of both sides. So the x minus 3 comes out because this square here and the square root cancel, equals plus or minus square root of 28. Well, what's the square root of 28? Only perfect square is 4 again, 4 times 7. So I get x minus 3 equals plus or minus 2 radical 7. Problem is, we are not done. I still got a minus 3 over here. So what's the opposite? Add 3. Now here's the tricky part. When I add 3 to the other side, I cannot go adding it to this 2. It's attached to a radical. So that's like saying 2x. So if I had something like 3 plus 2x, you wouldn't say, hey, it's 5x, okay? Remember that from all your basics. So when I do this, this is your final answer. You cannot complete the 3 with it. So you leave the 3, and then your plus or minus 2 radical 7, and believe it or not, that is your answer. You got a number here by itself, and then yes, you have a number attached to a radical, but you got to treat that like a variable. Those are the two. Could I write 3 plus 2 radical 7 and 3 minus 2 radical 7? Yes. But mathematicians, we leave it this way, and those are your two answers because of the plus or minus here. Unlike the ones we did previously, we want to add like 2 plus 5. You can actually add those two numbers together. These you cannot, okay? So don't be afraid. This is the way your answer will look. All right, exercise. All right, in exercise 4 here, we have this equation, y equals 1/2 x squared minus 6 on this grid below. So this is a quadratic we're familiar with because of x squared there. And he believes that the zeros are at negative 3.5 and 3.5 because obviously they do not hit at a nice intersection on either one. So 1, 2, 3.5 over. Pretty good guesses. He might not be exact, but that's his guesses. So the job is to find, in simplest radical form, the answer to this and see if he was correct or incorrect. Or why he must be incorrect. My bad. I guess they're already telling you that. So I take the equation up here, and let's do it. I set it equal to 0. So how are we going to solve? I'll bring the 6 over first. You will have a half x squared then equals negative 6. How do I undo the half? I multiply by 2, the reciprocal. So you get x squared then equals negative, sorry, it's positive 6 back here. So positive 12. And then you take the square root of both sides. When I take the square root of both sides, I get x equals plus or minus. And I know that 12 is 4 times 3. So I'm going to pull the 4 out as a 2 when I take the square root of 4. Radical 3. Well, if you plug it in your calculator, which is what the next part is, they want to know how far off were you actually on that one. Well, when I plug in 2 square root of 3, okay, on the calculator, plus or minus 2 square root of 3, and the nice thing is that's going to be plus or minus the same thing, that's equal to plus or minus 3.46 blah, blah, blah. So is he pretty close to 3.5? Yes, he is. But was he correct that it's exactly those answers? 3.5 is not unless they told you to round it off, okay? So he was close. Good guess. It looks like 3.5s and negative 3.5s, but not quite, all right? So always make sure you use your calculator to verify the answers. All right, exercise 5. Okay, the last one says find the zeros of this function. So you're going to set x plus 4 squared minus 20 equal to 0 if you want the zeros. And I'm going to pause it and let you do this. You should be able to solve this now and get a little practice. We'll verify that you did this one and tried it in class, okay? I'll come back to you in one moment. Pause the video, please. Okay, I hope you added 20 to both sides first. So I get x plus 4 squared equals 20. Once again, there's nothing on the left side except for what's in parentheses squared, so we're going to take the square root of both sides, plus or minus. So I will get the x plus 4 comes out, because that square cancels, equals plus or minus square root of 20. Well, once again, 20 is 4 times 5, so I'm going to pull out the 4. So plus or minus, and square root of 4 is 2, and then the 5 is still under the radical, so radical 5. Okay? You got one more step to go. We got to move the 4 over. So once again, I'm going to move the 4 over. I cannot add it to the 2 because once again, remember the 2 is connected to the 5 there. So my answer is, final answer is negative 4 plus or minus 2 radical 5. It's actually easier than if they were both numbers. Right? That's our final answer there, except they said round your answers to the nearest hundredth. So you got 2 things to do. You got to do negative 4 plus 2 radical 5 on your calculator. And you got to do negative 4 minus 2 radical 5 on your calculator. So please pause the video and go do that on your own and come back and check with me your answers. Okay, so if you added the 2 here, you got negative 4.4, what do I have here? Negative 0.47. Okay, so there's one answer. And the other one was negative 5.76. Those are the 2 answers you should have gotten, okay? All right, any questions, ask us in class tomorrow or replay it and see if you can catch on a little better. Remember, write a nice WSQ, and we will see you tomorrow in class.